Hey, welcome back. Last time we were talking about uh, cleaning up our run simulation function, and now we're at a place where we've got our simulation working. We're now able to simulate an SIR model, and we've made our code really nice and tight and and so that if we want to run our simulation, here's what we do. We we define what our beta and gamma are, which are dependent on the type of disease and the type of society that the disease is going around in. We have we've created our system object from the beta and gamma, and we have used our run simulation function to take in this system object and whatever our update function is to go from time t to time t plus 1, and the output is now a time frame object. So what we want to do now is, again, make another tight piece of code here that is going to give us the metric that we care about for our simulation. So we want to start off with our time frame object, and we want to get the information out about what metric do we care about. So some metrics that we might care about, which would be what is the total number of people who have been infected. Maybe we care about the maximum number of people infected at any one time. And then maybe about when does this maximum occur? When is this peak? And we might care also about when does the peak go below a certain threshold. So we have the number of infections ends up going down, and at some point it's low enough that we don't care about it, that the number of infections is trivial. And so when does the number of infections go below a threshold? All right, so here are different metrics, and what we might want to do is take our results, our simulated results, and see what those metrics are on those results. So let's focus on this one. What's the total number of people who have been infected at any time? And I wrote any one time, but what I want to mean is to be infected at any time during the whole uh, sickness. So let's see. What we want to do. Let's look at our situation. So I'm going to draw two pictures. The first picture is our population here. So our initial population at time 0, so we could say time is equal to 0, and then we have time is equal to time end. So at the beginning, we've got some amount of people who are susceptible. And you know what? I think I want to consider yellow. Let's make that yellow. Oops. All right, so we've got some susceptible part of the population. We've got some infected part of the population. and we have some recovered part of the population. Recovered or resistant. So this is going to be our S, our I, and our R at time 0. And so over time, some of the people who are susceptible get infected, some of the infected people recover, and then all the recovered or resistant people stay that way. So at the end of the time, where are we? We are at a situation where we have people in recovered, maybe we have some people still infected, but probably if we're thinking about near the end of a pandemic, we might think, oh, that number of infected people is almost 0. And so we have a transition here to going from the number of susceptible people, the SIR at the beginning, to SIR at the end. And the question is, how many people got infected? How many by this disease? So how can we measure this? Well, what we're going to do is we're going to say there's some number of people here who started off susceptible and stayed susceptible. And everybody else here, they got infected and eventually recovered. So in order to calculate how many people got infected from time 0 to time end, then the number of people who were infected during the course of time is the S, the number of susceptible people at time 0, minus the number of susceptible people at time end. So this is, we have this idea, now we need to extract that information from the time series. So create a function that does this. We're going to define a function called calculate total infected. And from there we need our initial, we need our data that was collected, or that was simulated, and we need our system object. And what we're going to do is we are going to figure out what our initial S0 was. So we need to, this is where drawing a picture of what our array would be helpful. So let's draw that here. Let's draw this on the side. We have our time frame. Remember, our time frame looks like this. T goes from 0 up to T end. And then we have S, I, and R. So this whole thing here is results. So what we want is the value S at time 0 and S at time end. And then we want to subtract the two of them. So how do we do that? We need to do results.s gives us this column. This is results.s. And then we want the first value. So this is time 0. If you're dealing with a simulation where you aren't starting at time equals 0 and instead of t0, you'd have to tell us what the t0 was here. Then we can talk about s end, and that's going to be results.s at this end time. And this is why we need our system object, because that's where our end time is stored. System.tEnd. So now we know our initial S value and our end S value, and what we need to then return S0 minus S end. And so now we have a function that extracts the metric from the time frame. And you just bring in what the results are, what the system object is. That we now can put this into our code from above. So let me just bring this down. Copy. And so this is our code that we really like because it does everything we want it to do. It runs the simulation. And now what we're going to do is we're going to collect our metric. All right, so our metric, that's a nice color, metric. So let's define this. We'll say metric equals calculate total infected of results and system. All right, and so we are going to use this. See how nice and compact this is? This is doing all the things we want. It's creating our system object. It's getting our time frame, which contains all our results. It's calculating our metric on our time frame. And then what we'll be able to do is we'll be able to use this to run our simulation many times and get information from it many different times. We're not quite there yet. The next thing we want to do is we want to put in a intervention. Let's try to reduce the number of people who got infected by introducing some vaccines to the system. All right, so we'll do that in the next video. See you shortly.